that. And there's the last one. All right, everybody is here. Let's get started. Good afternoon, everybody. Hello, welcome back. Here we've got semester 2. I hope your break was super awesome. Mine was pretty good. Got a lot done. Maybe not as much as I really wanted, but I got a lot done. Got a lot of relaxing and just time off. It's good to take a break and rest every now and then. It's very important. So I hope you got some of that. I also hope you enjoyed the reading that I gave for you over break. When I first read that thing, it changed my entire outlook on math. And so we're going to spend most of today into a deep dive based on that into the very nature of math itself. Okay, I've spent probably too much time thinking about what is math exactly. And so I would like to share with you my findings and my thoughts on that. And feel free to chime in. We can turn this into a whole roundtable discussion if you're up for it. Okay. Before we do that, though, I would like to draw your attention to this guy here. I sent an email yesterday with some reminders on expectations, structure of the class, as well as some major changes coming down the pipe this semester. So let me run through those real quick since I have you here. You are required to attend 2 classes each week, one of which is your color day between Monday, Tuesday, Wednesday, and one of them is the Friday, at least for those Fridays that we do have class. Okay? And Friday will always be online. Your color day, you can either show up in person, thank you. It's kind of empty in here. We could use more bodies in here, wouldn't you agree? Like, wouldn't that just be a better class? If you could actually turn to a physical person and be like, hey, what did you get on question number 5? Right? Isn't that way easier to do in person? Right? We could do some collaborative stuff. It could be really cool. So it's totally safe. There's plenty of room. Please come in if you can. Otherwise, show up online, right? And so those are the 2 minimum required, at least for attendance purposes, right? I gotta take your attendance on those 2 days. But the other days, I still expect you. Yes?
Sorry. What if on the Friday
You what? What if on the Friday, beep, beep, beep. What? Come back, finish the question.
Can you hear me now?
Yes.
I said, what if, so you said a requirement is to come in 2 days a week, right? But what if that one Friday out of the month we have work? Would that be the only exception?
Well, I said, yeah, on the Fridays that we actually have class assigned, right? It's not every Friday, not literally every Friday. But the schedule works out to be about, most of the time, it's 2 days a week. One of the weekdays earlier and then one of the Fridays. Right? Yes, there's some Fridays you have work, some Fridays we have holidays off and all that. Right, so I can just jump down here to point number 6. Right? Fridays are a grab bag for that very reason. We don't have all of them. So I can't reliably say, oh yeah, there's always going to be this on every Friday, because we don't always have every Friday, right? So some days will be a regular kind of lesson, some days will be some assessment, and other days, just like we did last semester, we'll just play games, because I think math games are really valuable in expanding your thinking in new directions, okay? So you got to at least show up to those. Those you have to report in so I can take your attendance. The other 2 days, your non-color days, so for you guys today, right, Tuesday and Wednesday, you're still responsible for that material. I still want you to experience those class days. You can do that live if your schedule allows, and you can tune in that day. You got an afternoon class, so if you're like sleeping in past 2 o'clock, you got other problems, okay? Don't do that. So you can tune in live on YouTube, right? Do we have anybody watching live now? No? Okay, that's fine. Or you can catch it, the recorded version later, okay? I don't care when you view it, just as long as you do view it that day and complete whatever the classwork assignment for that day by the end of the day. Okay? So those parts are still expected. And that's to enhance your learning. All right. In addition to that class part, we've got the weekly writing activity. That's still coming, right? The new reflection prompt each Monday, due the following Monday, so you have a week to think about it. Each weekend, we'll be reading a part from the text and taking notes. Okay? And the reason I have you read that first in preparation for the topic of the upcoming week is so that if you are confused, if you do find yourself questioning things about the new topic, okay, you encounter that in the textbook first, and then you can come to class and ask those questions, rather than come to class first and then realize afterwards, oh shoot, I actually don't know what this is about, and then, well, too bad. Now you just have the textbook to hopefully find the answer, right? You have a better chance of being able to ask it live. You can, of course, still always email me at any time when you do encounter a question, but this helps prep for that a little better. The quizzes, we're still going to have those pretty much every week, except now I'm moving them to Mondays. So it serves two purposes. One, it acts kind of like a reading quiz, so it holds you a little bit accountable to make sure you get that reading done each weekend, but also serves for you as a measure of how well you absorbed the material from the reading, versus if you don't do so well on that, maybe like, oh, maybe you need to go back, review a little bit, maybe. That's the thing you should pay attention to extra hard in class. You'll be on the lookout and be like, I got that one wrong on the quizzes. Ooh, Mr. Apple's talking about it. Okay, extra focus time, okay? So it sets you up to know where you need to put forth your effort, as well as gives you now the whole week to do the retakes instead of just a couple days at the end. You get a little more time there, so I hope that helps you out. SAT practice, similarly, I've moved that to the weekend. So it will post on Thursday morning. You have until Monday to complete it. And that's just to try to help alleviate some of the stress on Friday. I know a lot of things were due on Friday, not just this class, but on all the other classes. So I'm hoping to kind of lift that a little bit and try to spread things out better. Let me know how that works. In addition to lightening the load, I've removed the online software bit. We're no longer using Studycom. We've dropped that entirely. Right? I liked it as an extra resource, another thing you could turn to for help. Also, it provided the immediate instant feedback of the computerized questions. But I think the drawbacks outweighed the benefits. It was too confusing to have yet another thing that you needed to log on to and find and use, and stressing you out due Friday kind of thing. So I've just dropped it entirely. We're just going to have the straight up book problem assignments associated with each day. There's not going to be this week-long homework item. That being said, the length of those assignments for each class day are going to vary a little bit to kind of compensate. It's not like the total workload has suddenly cut in half. Okay? They'll be a little bit beefier, but tomorrow I'm going to talk about the study levels. And this is where you will get a chance to kind of customize the length of the homework assignments, okay? Some of the questions will be optional, and I'll talk more about that tomorrow. And this allows you the flexibility to engage in whatever level of depth you're ready for and want to deal with. Okay? Speaking of tomorrow, if you're ever wondering, what are we talking about the next day? You can always look at the master schedule, okay? That's still a super awesome Google Sheet available there on Google Classroom. You can link right to it, open it up, and see, spread before your eyes, the entire plan of the year. What are we talking about? When is this? What's due? What's the activity? What's the assignment? It's all there, color-coded for your convenience and mine, because this is literally the thing that I use to plan out the year. Okay, I don't have like a paper calendar that I fill it in first and then, no, I do it directly on the Google Sheet. So as soon as I figure out what we're doing, you can know what we're doing. So check that often and you won't be caught by surprise by anything. All right, and then I mentioned Fridays. So that covers all of those items. I hope that clears things up and sets the stage for the new semester. Any questions on those elements? Good. Okay, then let's dive into the real meat of today. What is mathematics? What is its nature? What is its definition? Part of this kind of started with this article. I don't know if you remember this way back at the beginning of the year. The one-word math classes. This guy found a way to turn all of the different years, the different topics within math, and reduce them down to a single term. Algebra is the mathematics of relationships. Geometry is the mathematics of space. I thought this was pretty good. This is a really nice summary of like what it is you'll be studying throughout the years, right? This year we're studying space and shapes. Algebra, you go back to different relationships. When you get to calculus, that's the mathematics of change. Oh, shoot, now all of a sudden things are fluctuating and changing. How do we deal with that? That's what calculus addresses. But what if you want to summarize the whole thing? Notice all of these subjects within math, their definition is the mathematics of item. Well, what does the mathematics part mean? What does that mean to be math? What does it mean to do math? I've been struggling with this for quite a while. Okay? When I studied physics in undergrad, it was very straightforward. Physics, matter and energy. You could actually define physics as motion of matter and energy. Even electricity is moving charges, right? It is motion. Physics is the study of motion. Biology, there's an easy one. Biology is the study of life. English class, study of English. Okay, but more generally, right? Your language arts class, whether you take it in France and it's all in French and you call it French class, okay? It's the study of communication. Right? There's some pretty good defining like single word terms for this subject. History is in the name. Right? Study of the past. What is math the study of? Can you reduce that to one word? I've never been satisfied until very recently. Math is the study of mathematics. That's a tautology. You can't use the word in its own definition. You know that, right? That's no good. And here's part of the problem, is it all goes back to, well, what are we doing with math? We're thinking about it. We're solving problems. That's one of my main overarching goals, is to help you guys solve problems. In fact, this semester of geometry is dedicated to problem solving. If you take a look at the master schedule, you'll see I've got different tabs for each quarter. The first quarter was the logic and reasoning. Second quarter was the SAT geometry, all of the geometric facts and formulas that you will need for the SAT. I was actually surprised that it was such a short list. It was a jam-packed quarter, I'll grant you that. A lot of stuff to take in. But we did it. It did fit there. It would have been nice if we had like a couple extra weeks to pad it out, but not that much more. You don't need a whole semester for it. And so this semester, I'm taking all of those facts and formulas, and we're going to now apply them to solving problems, right? We'll start with simple two-dimensional problems, work our way up to more complex and three-dimensional problems. But what is a problem? What is a math problem, truly, versus a math exercise? What does it mean to think mathematically? What does it mean to think in the first place? Like, all of these things I try to define. Well, this is using that. Well, what is that thing? What is that thing? Like all of these words within the definitions, you have to define those too. This is what I've come up with. So I've thought about this for several years now, and ruminating, trying to put this into words so that I could understand it myself. Okay, this is not just, how can I teach this thing to you? No. I've been trying to figure this out for me, because I'm curious. I want a good, succinct, what is math? How do you use it? How do you solve problems? And once I have that, then I hope to share with you and teach you, here's what math is, here's how you can use it, here's how you can solve problems. So follow along with me. This is my thinking process. This is what I've come to. I would say that real thinking, true actual thought, right, is putting ideas together in a different combination and seeing what happens. Okay? Imagine it's a little mental experiment in your head. Okay? Chemistry class, you got all these chemicals sitting there in the beakers, and you're wondering like, ooh, what happens if I pour this one into that one, right? Will it change color? Will it make smoke? Will it explode in your face? Who knows, right? That's why teachers always, very warning, dangerous. Don't just randomly mix chemicals. You're like, well, why not? What's the worst that could happen? You kind of want to know. It's this morbid curiosity, right? That curiosity, that new combinations, that's part of thinking. Okay? It's different from the retrieval of facts. Okay? If I ask you, what's 2 plus 2, and you immediately respond 4, because it's automatic. You know that one so well. That's a retrieval of a fact. That's not thinking, even though it's happening in your brain. Thought is not everything going on in your mind. Retrieval of a fact is simple. Your brain can act like a library. It houses and stores a lot of information, and you can go look, browse the shelves. Oh, there's one. You pull it out. And, oh, here's 2 plus 2 equals 4. I know that. You've got that memorized. Okay? You've also got, here's 4 plus 4 equals 8. You've got that one memorized, right? And you can pull those facts out. And you can regurgitate them, repeat them to me. A parrot can do that, okay? Repeating a known fact is not thought. Thought is putting the ideas together. It's taking 2 plus 2 equals 4, 4 plus 4 equals 8. Look at those two, compare them, contrast them, find the pattern. Well, how does this one go into that one? How do they fit together? What's going on here? What's the underlying thing? What if I combine the two together? How can I combine the two together? Do I just add up all the things? 2 and the 4 is 6. 6 plus the 6 equals 12. Do I multiply them? Right? There's different ways to put these things together. That is the thought process. Okay? And that directly ties to solving problems. Problem solving is a thought process. Because, this took me a while to figure out, okay, the difference between a problem and an exercise. The surface level, an exercise is something you already know how to do. A problem is something you don't know already how to do. Exercise might not be easy, but it is simple. It's straightforward. You go to the gym, you lift weights. That's exercise. You already know how to bend your muscles, okay? That's not new. That's not novel. It's not difficult and complicated, okay? But you repeat it over and over so you do get better at it, so you get faster at it, right? So you no longer have to put in as much effort to still get it done, right? But say they invent this new machine in the gym. You're like, oh, how does this machine work? You climb on here, and then you grab this, and you pull that. Like, you got to figure it out, right? You haven't used it before. Well, now it's more of a problem. The problem is a new combination of inconveniences. Because once you've figured out the machine, now it's, okay, now I got to set the lever here. I go there, I grab it, and you pull, right? And you work out. Well, now it's back to exercise, right? Once you've figured it out, it's just a new exercise to you. Here's another example. Changing a light bulb at home. If my desk lamp burns out, bulb dies, I got to change the light bulb. It's an inconvenience, but it's merely an exercise. I know how to change the light bulb. Unscrew the old one, I go to the closet, I pick out one of my light bulbs. I have all the same light bulbs in the house, so I go take that one, screw it back into the lamp, done. Light bulb changed. Inconvenient, sure. It took time out of my day. Didn't want to have to do it, but I did it. It didn't require much thought because it wasn't new. What if I had to change one of these light bulbs here in the school? What if this light burns out on me? I've been saying this, 5 times today, and it hasn't happened yet. It'd be really funny if it actually did when I said it. What if this bulb's out? Oh, gosh, right? What if it did? How would I address that? What would I do? I have no idea what kind of bulb this thing takes, right? These light fixtures are a long rectangular box, rectangular prism to be specific, right? It's entirely enclosed. I can't even see the actual shape of the bulb. I assume, because it's such a long rectangular box, it's probably one of those long tube fluorescent bulbs. That's what seems to make the most sense, but I don't know. It could be a whole bunch of it. It could be a strip of LEDs in there, right? Actually, if we were really efficient, we put this thing together, that'd be the best one, right? I don't know. So first I got to open it up, figure out what kind of bulb it is, right? How am I going to open it up? It's way up there. I can't reach it. Oh, okay, now I got to get a ladder to open it up. I don't even think I could reach that standing on the desk. So I got to go find a ladder somewhere. I have no idea where we keep the ladders. Okay? I honestly don't. Probably somewhere at the garage-ish, but there's all the storage over there with the construction. Maybe they have a ladder. I don't know. Right? I'd have to find a ladder, get the ladder, bring it over here, open it up, see what kind of bulb we have, find out where we keep the light bulbs. Is that next to the ladders? See where I'm going with this? Maybe I circumvent that entirely, but you know what? I'm not responsible for the light bulbs in the school building. I'm just going to call the guy in charge. Who's in charge of the light bulbs in the school building? Do you know? I'm not even sure myself. I can think, I have a short list, all right? I don't know which specifically. So even that alone, you can't even circumvent the issue without it still being some kind of a problem. It's a new combination of inconveniences. Because once I know where the ladder is, I can go get the ladder, bring the ladder here. When I know where the light bulbs are, I can go get the light bulb, bring it here. Once I know how to open up this fixture, I can open that up. Fairly straightforward. It's a combination, multiple little steps that I each know how to do now. Now it's not a problem. Oh, light bulb's out again. Okay, go get the ladder, go get the bulb, change it. It's just a long list of exercises. See the difference there? So that brings me to this next topic that often comes up when people talk about these things, and that's intelligence. And oh my gosh, I realize you haven't had the visual to go with this. We've been staring at that list there. I'm so sorry about that. Let me start over then. Right? Thinking, putting ideas together in different combinations, seeing what happens. Problems are novel combinations of inconveniences. Intelligence, then, sometimes defined as the ability to solve problems. In fact, many intelligence tests, so-called IQ tests, they claim to test your ability to solve a problem. It's not entirely true. It's your ability to solve a problem quickly. It's the difference between a timed test and an untimed test, right? If you've been paying attention to how our principal reports our testing scores, you might know that our school does really well on the MAP test. The MAP test is untimed, right? You can take as long as you want to answer those questions. We do phenomenal as a school, right? On timed tests, such as the SAT, I mean, we don't do terrible, but we're not as way above there. Because of that timed nature, all of a sudden, that pressure, that changes things. And so it makes us look not as good. But the only difference there is speed. You can still answer the question. Okay? Intelligence, when people say, oh, so-and-so is really smart, or you're really good at math. Good at math. No such thing. Being good at math just means you do it faster. If you're bad at math, it doesn't mean you can't solve the problem. It's just going to take you longer. Okay? In some contexts, yeah, that can be a problem. But in many real-world situations, it's not an issue. You just take a little more time with it. You're probably good at something else that you're much faster at, and you can save time elsewhere, right? Some people are really fast at typing, and they make up for the math thinking time with typing up their answer. See the difference there? So don't be put off by the so-called intelligence or lack thereof. It's just speed, right? Guess what? When something is no longer a problem for you, because it's no longer novel, it's not new, you've seen that before, it's now just an exercise, now you can practice it. Now you can get faster. And if you can get faster, you can think and solve quicker. That's building intelligence. That is something we are striving to do in math class. Build up intelligence. So what is math then itself? Math requires all of this thinking. Why? What is math studying? What's it doing? Is it science? Science, they say, is the pursuit of knowledge. Comes directly from the Greek word for knowledge. Okay? Are we pursuing knowledge in math? In math class? Not really. Usually in math class in school, and this is the mathematician's lament, this is part of it, is the fact that a whole bunch of other mathematicians back in history, they already found this stuff. They already figured this out. They pursued that knowledge, they found it, they presented it, they said, here's our findings, and we're like, that's great. Now we memorize it, right? They've been dead for hundreds of years. There's no more pursuit going on, right? Truly doing math, if you find a modern day mathematician What are they doing? What is their day-to-day job? They're doing this. They're pursuing new knowledge. They're trying new combinations. They're thinking about this stuff, putting new things together. Be like, hey, has anybody tried adding this plus this? And they're like, everybody else said, you can't add apples and oranges together. Those are two different things. And the mathematician's like, yeah, but what if I could? Right? That's how we ended up with negatives. Somebody said, yeah, but what if you could? That's how we ended up with complex numbers. You can't take the square root of -1. Yeah, but what if I could? What if? What if that curiosity? What happens if I do this? Right? That's science, pursuit of knowledge. What comes out of it, we classify that as objective, right? The scientific community, we have multiple people try the same thing. They all get the same result. We accept that as true. It's objective. It acquires new established knowledge that we can count on it, and it's reliable. Art, on the other hand, is making new combinations, creative combinations, new thought-provoking combinations. Remember, thought is combining new ideas together. So art is new ideas together. Art, then, by its nature, is subjective. It depends on the person making it, depends on the person interpreting it, right? And it expresses knowledge. Here in the gray, this is what I came up with. In the blue, I've added, this is directly from some of my research, and I really like the contrast between these definitions. Objective acquisition of knowledge versus the subjective expressing of knowledge. Art does not create new ideas. It doesn't create new knowledge or find new knowledge, but it expresses it in a new, unique way, right? Artists don't uncover new colors, right? They might find new sources for pigments in a very scientific way, but as far as the spectrum of light is concerned, right, there's only so many specific wavelengths. Those are the colors, okay? You can't change that. But they can come up with new ways to paint it on the canvas. Put the red on this side, and some green over there, a little blue up top. And a different artist will put the red over here, green over there, and put the blue on the bottom. You've got a whole different painting, right? That's the artistic part. It's creating that new combination. Is that mathematics? Can we do that? Can we express combinations of ideas with math? Absolutely, right? Look at this. We can create some math right here. Let me whip a little picture up. We have found this shape, you know, a very scientific process. We've defined it rigorously. 3 sides, 3 angles. It's the triangle. We gave it a name. It has properties. We can study those properties and uncover them. Or we can take those things and we can combine them and say, well, what if I put a triangle inside another triangle? Right? It's not a new idea. Or what if we made a bigger triangle around that triangle, right? We could go on and put little triangles inside of the other triangles, or if you do a little triangle in this triangle, right? And suddenly now we've created art, right? We've created something with those old ideas, new combination of old ideas. That's an artistic thing. So math has components of both, for sure. And I'm going to go one step further. I'm going to say math not only has an artistic expression, there's a specific artistic expression in math, and that is language. You may have heard the long term of your English class, English language arts, right? Language is a type of art. It's an expression, right? It's a way of communicating ideas. We've gone from cave paintings to written and vocal language so that we can communicate with other human beings. Okay? It does you no good to uncover the new mathematical secret of the universe if you can't share it with anybody. You've got to have a way to talk about it. So we created a language. This y equals mx plus b. That's math. Right? Nobody's going to doubt that. Like, that belongs in the realm of math. That is definitely a component of mathematics. It's an equation, right? It expresses an idea. In fact, we have the term mathematical expression, or part of an equation. You just take a piece of it. It's an expression. It expresses an idea. We understand that. We can look at that. We can read that. We're like, oh yeah, that's a line. That represents a line, and we can visualize that. That's a graph, right? It has a slope, but has an angle to it. It has a size, and length, goes on forever, right? All of these ideas, all these pieces are communicated from me to you by nature of these symbols here on my tablet. That's language. There's a vocabulary, right? Line, slope. There's symbols that I can write. I write them in a very specific order. Note that if I move the symbols anywhere in a different order, I get a different idea. So there's like grammatical rules to this too. You can't just write them wherever you want. That's very much a language. In fact, I've often thought we could do better to teach mathematics class as a language. Treat it like we do with a language class. We've got vocabulary, we've got grammar rules. You know, do we need like spelling tests in math? Not to like, can you spell the math terms, but what would the equivalent be? Right? Every week you need to be able to put these ideas together, re-express this thought. So I needed one word, one definition. You can't just say math is a science. The science of what? It's not the science of life. It's not the science of chemicals, molecules, atoms. What is math the study of? What sorts of ideas are math and are not math? Because I've often thought, hey, that algebra one, right? Algebra is the mathematics of relationships. That's pretty good. Relationships describes a lot of math, even the non-algebra stuff. You could say geometry is relationships. It's just spatial relationships, right? It's a different type of relationships. So maybe actually all the math is a study of relationships, and then there's the different kinds of math for different kinds of relationships. Except it's too broad. Too many things are relationships, right? English is also relationships of ideas. Relationships between words and sentences. History is full of relationships between people and peoples, right? So that doesn't work. That covers everything. It's too broad. I need a little bit narrower, but still grab all of math. Literally been thinking about this, trying to find an answer for years. Finally found one last semester. I will share it with you now. Really good one. Math is the study of structure. Math is the study of structure. Rules for things. Rules for those relationships. Right? English can put those relationships, can describe them, but math is the one that says, no, I want to be very precise. This isn't just, this is bigger than that. How much bigger? We want to create a system of measurement to know exactly how much bigger. It's precision, right? That's what the math adds to it. And so this study of structure is something that can stand alone by itself. We have math class, we've done that. What are the nature of these structures? And be applied to other things. You can impose a structure on biology, chemistry, physics. Say, oh, it's not just, gravity gets more powerful the closer you are. That's a descriptive term, but mathematically we can represent that structurally with an equation. We can plot and measure and be precise with it, right? In fact, math is not only the study of that structure, but the term mathematics also needs to carry with it a secondary definition. This is why it was so hard to find a good definition. I can reduce it down to one word, the study of structure. But I also need to understand that this term mathematics refers to the language to describe said structures. Those equations themselves represent their own ideas, and the equation as written is itself an idea that needs to be included. So we have to have both. We understand that math is those structures, and it's the language to express those structures, to describe those structures. And that's partly what makes it so useful and so confusing at the same time. These two different levels you always have to deal with. Okay? Now, I think application of structure onto other disciplines is fairly straightforward. You can definitely see where the math comes up in science class for sure. History class, you got to do a little bit more digging. English class, a little bit more obscure. Okay, take any poem with a structure to it, right? You got a rhyming scheme, that's a pattern, that's a structure, that's math. Done. Okay? But we can even apply the structure purely into the real world directly. That would be architecture, right? Real world physical structures, right? Building houses. There's a structure. There's a structure, right? We can put them together. Everything that's built around us is inherently mathematics, because there's rules to describe how these things go together and why. Here's the secret. This is why I love this definition so much. The use of structure automatically gives us a purpose as well. Structure helps reinforce a purpose. Rules reinforce purpose. The reason we have rules in a classroom, okay? It's not because we hate your freedom and we just want you to be miserable and no, you're not allowed to chew gum or talk out of turn, you must sit in your chair and all that good stuff, right? The rules exist for a purpose because they create the structure of the classroom. There's the physical walls and ceiling and chairs and desks, but the rules create the atmospheric, the metaphysical structure for learning. They serve a purpose, creating that environment best suited for learning. Just like a physical structure, a building is an environment best suited for whatever's going on, right? We built this room to accommodate, hey, classes of this size work well, so we need a space that's this big, right? Meeting rooms, right? Look at the Congress, U.S. Congress building, right? Gigantic stadium seating so you can accommodate all of these people that need to talk together. Here's another one. What about just as I've drawn there? A lot of our houses have sloped roofs. There's plenty of buildings out there that do not, especially like down southwest, right? Arizona, New Mexico, the good old Native American Pueblo buildings, all flat, square, flat roofs. Why is it that they can get away with tons of flat roofs? Well, you should not build your house with a flat roof here in Illinois. Why would that be a bad idea?
Snow.
Snow. Absolutely. And even more generally, any precipitation, rain, right? Sleet, hail, snow, all of that pouring down onto your roof, you want it to be able to fall off, right? A flat roof is going to accumulate snow. Snow gets heavy. You compact it. It turns into ice, even heavier. You're going to impose damage, right? Bad things are going to happen. We need a slope roof anywhere there's snow so they can slide off. Okay? Otherwise, you got to get out and shovel your roof, which is kind of ridiculous. Yeah, so those structures, like that difference alone, based on the environments, we have different needs, different purposes. So we created our structures to best serve those purposes. That's architecture when it's applied to the physical realm, real world building of things. Math is the study of any type of structure that has a purpose built in, depending on how you want to apply it or not apply it, right? You can study it purely for its own enjoyment, right? That bit of curiosity. It's not as flashy and colorful as mixing random stuff in chemistry class, but it's still there. We can see, hey, what happens if you put this kind of structure? If you try to combine these things using that rule, what happens? Weird stuff. And if you find something new, you figure out a way to describe it and share it with others. That's mathematics. That is our foundation. That is what we are studying this year. That is what we will use to solve new, cool problems. Any questions there? All right. Then you've got 5 more minutes. Go ahead and use that time to wrap up those 6 questions? 6 questions for today, those discussion questions. Draw from the article, Mathematicians Lament. Draw from things I've said. Draw from your own ideas. I want to hear from you. What do you think about this? Do you agree that math is a science and an art and a language? Is it more of one than the other? There you go. That's what I want. Inject your opinion there into which you think it's more of. Okay? Don't just say yes or no, it is. Like, put as much detail in as you can. Describe how is math a science? Why is it a science? Do you think it's more science than art or more art than science, or is it equal? Is it 50-50? I'm not sure on that one. There's always a new question to consider. I'll have to think about that. So I want to hear from you first. So include that in your answer there, comparing science, art, and language for math. All right? And that's it for today. That's the only assignment. Future days will have additional, actual math exercises and problems to go along with it. But this is it for today. Once you've finished those questions, turn them in, you are done. Can we do this from only our opinion, or do we have to get it from the combination therein? So based on what you've absorbed from the reading and what I've said today, give me your opinion. You could say you agree or disagree. It said this, but I still think it's that way. Perfectly acceptable. Right? In an ideal world, there would have been more of us in here, and we could have turned this more into a round discussion. I don't know how the English teachers do it. How do you have discussions over Zoom with a third of the class at a time? I'll have to pick their brains on that one.